Okay, today we are going to start getting into how to do proofs of statements. Okay, and I'm going to show you about 8 rules of inference, okay, that you use to take some given information, those are called premises, and then you use these rules of inference to form a conclusion. The book has 3. I'm going to give you additional ones besides just what is in the book. Okay? All right. So the first one is where you are given P implies Q, and you are also given P. What can we conclude from that, do you think? If P implies Q and we're given P, then what can we infer? We can infer Q, right? Such as, if it is cold, I will wear a jacket. Along with the information, it is cold. So what can you infer? You can infer that I will wear a jacket. Okay? That is a very well-known rule of inference, and it is called modus ponens, which is, I believe, a Latin name. Okay? And it has a very similar partner called modus tollens, which goes like this. If we are given P implies Q, and we are given not Q, then what can we infer? We can infer, or I prefer the word conclude, not P. Okay? I used to know what those terms modus ponens and modus tollens stand for, and I don't remember because they are very, very awkward. I think modus ponens means something like the method of verifying by verification or something like that, and modus tollens is something like the method of, I don't remember, the method of contradicting by contradiction or something like that. I don't know. It's very awkward when you translate them into English, and so it's hard to remember exactly how they go. All right, now the book also shows us this one, number 3. I will label it. It's called Elimination. Okay, and that says if you are given the premises P or Q, and you are also given not P, then what do we conclude from that? If we have P or Q and we don't have P, then we must have Q. Okay? All right, now I'm going to give you, oh, by the way, really quickly, I don't think we need to write this down as a separate thing, but I will just show you really quickly that this is also called elimination. If you had P or Q, and then you were given not Q, then you could conclude P. I don't think that's necessary to write that down as a separate thing. But if you used it that way, that would also be a case of elimination. Okay, now I'm going to give you about 5 more that the book doesn't seem to spell out, which is fine, okay, but I think this will be useful for us. Okay, so what order should we go in? Let's do specialization next. My computer is being bogged down by trying to produce another video at the same time I'm writing this. And that's why some of the writing will look a little bit messy, maybe. Like that. Okay, I'm going to stop for a second. I'm going to pause that other task. Okay, let's see if this is better. All right, so specialization. This is where you're given a statement P and Q, and given that one statement, we can conclude P. By the way, I also could have concluded Q as well. Either of those, that is called specialization. What's the opposite? Well, not really opposite, but sort of the other side of the coin from specialization would be number 5, generalization. This is where you're given a statement P, and from there we can conclude P or Q. Let me fix that. Looks almost like a union symbol. Of course it should not. There we go. Okay, and another example of specialization would be if we are given a statement Q and we conclude P or Q. Okay. What if you wanted to conclude P and Q? If you had P, would that be enough to conclude P and Q? Or if you had Q, would that be enough to conclude P and Q? Neither one would be enough, right? In order to conclude P and Q, you would need both P and also Q. And that rule of inference is called conjunction. If you're given P and you're given Q, then you can conclude P and Q. You're not really concluding anything that you didn't already have. It's just that you're taking two separate statements that you're given and putting them into one statement. Okay, two more. Transitivity is next. That should be number 7. Okay. So this is where you're given a statement like this. P implies Q, for instance. And then separately from that, you're also given the statement Q implies, let's say, R. Okay, given both of those, remember the statements you're given are called premises. So given those two premises, we can make the conclusion that P implies R. Okay, and the last one we're going to call proof by cases. Okay, and that is you're given P or Q. You're given that P implies R. And you are given that Q implies R. And from those three premises, hang on, let me fix that. From those three premises, what can we conclude? we can conclude are. Okay, so those are all called rules of inference. And you can use these to prove things. So I want to go with you a proof and show you where each of these are being used along the way. Suppose you're going to take your dog for a walk and you're looking for the leash, okay? And suppose that you have these 5 pieces of information. Okay, first thing you're given. If you came back from your previous walk through the front door, the leash is in the entry closet. If you came back from your previous walk through the kitchen door, the leash is on the kitchen counter. If the leash is on the counter, then you saw them, or not them, sorry, you saw it at breakfast. You came back from your previous walk through the front door, or you came back from your previous walk through the kitchen door. And finally, you did not see the leash at breakfast. Okay, now I want you to just stop the video if you need to. I want you to look at these 5 pieces of information. I'll label them, okay? These are premises that you are given. And I want you to decide where the leash is and think about why you know the leash is there. Okay, go ahead and pause the video and think about that. And then start the video back up again. Okay, so hopefully you figured out where the leash is. It's in the entry closet, isn't it? And if I asked you to, prove that to me, I mean, other than going to the entry closet and getting it, but, convince me logically that that's where the leash is, you could probably do so if I asked you to point out along the way where you are using each of these 8 rules of inference. That might be a little bit harder for you because we do not usually force ourselves to do that. So that's not something that you are probably in practice of doing. Okay, if I asked you to say, well, because of modus ponens, then I know this is true. And then because of that and conjunction, then this other thing must be true. You know what I mean? That is not something that we normally learn how to do as we're growing up. So I want to walk through it with you, and I want us to point out where we're getting every single bit of information from. Okay? So, first of all, in those 5 pieces of information that you're given, those 5 premises, there are also 5 simple statements in there. So each of those 5 blue things is a statement. That's true. But inside of them, there are 5 smaller statements, like the first one. If you came back from your previous walk through the front door, the leash is in the entry closet. There's 2 statements inside of that one statement. One is you came back from your previous walk through the front door. And another statement I see is the leash is in the entry closet. And then premise number 1 says, if the one, then the other. Correct? So let's do this. Let's write down the 5 basic statements and let's name them. So first, I'll write these in green, okay? So first I'm going to write, let's make that a little bigger. Okay, so let's write you came back from your previous walk through the front door. Let's name that something. How about let's name that FD for front door. Okay, and there's a similar one about a kitchen door, right? So let's go ahead and write that one down right now. You came back from your previous walk through the kitchen door. What do you think we'll call that? How about KD? Okay, what else do we have hidden inside those blue statements? There is the leash is in the entry closet. Oh, that's not how you spell it. Okay, let's call that statement EC. We have the statement the leash is on the counter. How about if we'll just call that one C? And there's one more in there. Do you see it? It's this one. You saw the leash at breakfast. That's all we need to write down. I mean, we could write down more, but my point is we only need these 5. We can get all of that information in blue from these 5. Let's call that last one B. Okay? So I think that you probably figured out where the leash is, that it's in the entry closet. Okay, let's work through a logical proof of that and point out the premises as we use them, and point out the rules of inference as we use them. Okay, so let me walk through this with you. The way that I would do it is not necessarily the only way, but here's how I would do it. So I would start by pointing out that KD implies C. In other words, if you came back from your previous walk through the kitchen door, then the leash is on the counter. How do I know that? Because it's given to me. That is one of the premises that I was given. That's premise number 2. Okay? What else can I say here that I think would be important to use? I can say that C implies B. In other words, if the leash is on the counter, then you saw the leash at breakfast. How do I know that's true? Because that's given to me also as a premise. That's premise number 3. Now, I could go further, but I can write down more premises, but right now, already, I can make an important conclusion. Do you see what I can conclude at this point? I can conclude that if you came back from your previous walk through the kitchen door, then you saw your leash at breakfast. Do you agree that I can make that conclusion? That would be KD implies B. And what rule of inference am I using there? I am using the rule transitivity. Oh, by the way, I noticed something here that I don't want to confuse anybody. I've labeled our premises very similarly to the way I labeled the rules of inference, and that might cause some confusion. So I'm going to go back here and change these labels to, how about if we will label them with, should we use Roman numerals then, so that we don't cause any confusion? So then in our proof here, the first one should say by Roman numeral 2, and the second one should be by Roman numeral 3. There we go. All right, now getting back to the question at hand. What rule of inference am I using to conclude KD implies B? I am using transitivity. Okay. Now, let's move forward from here. You might choose to go one way or the other. I will choose to point out this next. Oh, before I go any further real quick, I want to show you this symbol. Dot. I might have shown this to you before, but I don't think so. Dot, dot, like that. That is a symbol that means the word therefore. Okay? So I'm saying KD implies C, and C implies B, therefore KD implies B. And my reasoning is by transitivity. Okay? All right, now I'm going to choose to point out this next. Not B. In other words, you did not see the leash at breakfast. What is my justification for that? It is given to us as a premise. That's premise number 5. Okay? Now, based upon those two previous lines, KD implies B, but also not B. What can I conclude from that? I can conclude not, here we can say therefore, not KD. What rule am I using there? KD implies B and not B allow me to conclude not KD. That is exactly the rule modus tollens. Okay. I will point out next that FD or KD, you came through the front door or through the kitchen door. Why? That's premise number 4. So at this point I can conclude that you came through the front door. I'm going to write therefore FD. Why can I make that conclusion? Because I have, in the previous 2 lines, I have not KD, but also FD or KD. So isn't that simply using elimination? Just that I've got the 2 lines that I'm using for my justification there. I just have them written in the opposite order, but that doesn't make any difference. I'm still using the same rule of inference. Okay, what else? Now you're probably chomping at the bit at this point to say, Therefore, the leash is in the entry closet. But if you do that now, you're skipping a step, because at this point right here, there's nothing written in black there that even mentions the entry closet. So how would you make that conclusion? You still need to point out FD implies EC. And that's true because it's given as premise number 1. And then you can make your final conclusion. Therefore, EC. In other words, the leash is in the entry closet. And what's our reasoning for that last line? Look at the 2 lines right above it. I have FD, and I also have that FD implies EC. So that is modus ponens. It's just that I have my 2 input lines that I'm putting into modus ponens are just in a different order than they were written here, but that doesn't make any difference. So if you concluded that your dog's leash is in the entry closet, then you're correct. And that is the logical argument that gets us from our 5 premises to the conclusion that the leash is in the entry closet. And hopefully, by the end of the semester, you'll be very good at doing things like this. Okay, that's all for today.